in my slides, and I thanks you, and thanks also Sarah and Susan, the organizer, for inviting me here. And actually, I take this as an opportunity to present my ESC project. So there's no concrete results. Actually, I've started the project on the 1st of January. It's been almost 1 year and 3 months roughly. So 1st of January 2022. Since Hugh was mentioning it, I've been doing a lot of stuff. So it started not having enough time to do research. So that's a bit of an excuse that maybe I don't have yet a lot of results to present. But I want to share the ideas because I think it's an ongoing work. And I think perhaps it could also inspire you to work around this topic, or if you want to do some collaboration, I'm also happy to collaborate with you. So maybe since the topic is about climate change, I'm just wondering if you have some time, maybe if you can write in the chat, have you, whatever you define, it's your definition, have you personally experienced, or you're from yourself, extreme weather events or some events that you think it's triggered by climate change? And if so, how did it affect you? Like what kind of impact that you have felt? Yeah, so it would be nice to hear a bit from your own experience. I have to say, like, I started working on this topic. It's been about 10 years. When I started after Oxford, after the European University in Italy, I moved to Austria, and then that when I started working on the topic of population and environment. So 10 years ago, when I started, I think when you talk with people from Europe, for instance, to talk about climate change, it's something far away from our own experience. But now, at this moment, so typically also when I teach, if I ask the people, have you experienced climate change? Normally, it's quite close to home nowadays. And also, so there are two things, right? So in say 10, 15 years ago, when we think about climate change, we have a spatial distance. So it doesn't happen quite that much in places like Europe. And also temporal distance, because we think of climate change as something that is happening. It has happened, or it has started, but probably the impact it's going to be felt in the next 30 years or so. But it's not like that anymore. So I'm just curious to hear from you. If you can put down in the chat. What else I want to say? So please feel free to interrupt me. Either you, I may not monitor the chat that much while I'm speaking, but if the share would speak out the questions of our clarification, or you can just switch on your microphone to ask a question in between. I'm happy to do so as well. So yes, so then let's move on, and then I would look at the chat a bit. There's one question, one answer. Edith said that finally enjoying the British weather. Also, someone said a tornado in the Czech Republic, and tornado is also one of the event that recently there's more evidence showing that it's induced by human-made climate change. I think that's another point that I want to make. Maybe some of you may have already felt a heat wave, for instance. So the evidence from the natural science side about human-made climate change has also been quite solid nowadays to compare to say 15 years ago. So there's a science called climate change attribution, which what they do is they use the kind of observed, say, temperature data or rainfall data, and then use the counterfactual kind of statistical modeling to say that if there were to be no carbon emissions, which is carbon emissions is human-made, it's come from human activities, right? If there were to be no human activities induced carbon emissions, would we have observed such and such event, and would we have observed this irregular pattern in temperature and so on. And by using this type of method, they are able to attribute certain events that we observed, maybe the heat wave in the UK last year, for instance, to human-made climate change. So I think it's evidence on that side, so quite solid that it's human-made. And as I said, that it's probably some of the example that you put in the chat, like drought in the Lebanon. So some of these events have already been shown that it's done by the human-made. And the British weather, yeah, that's, of course, the impact is not distributed evenly across geographical regions, across population subgroups, and that's a kind of work that demographic work can contribute quite a lot. Also, the differential impact of climate change, and certain geographical regions may benefit in terms of, say, agriculture production, like the northern European countries, including Britain, that can grow. I don't know if some of you may notice that there's some wine and sparkling wine, kind of champagne-like, also already coming out from or produced in the UK. Yeah, so some introduction about impact of climate change, but I guess many of you may have work around the field of population studies or demography, and I just want to emphasize that we can contribute a lot to the research on climate change as with our background in demography or sociology, because human population is really at the center of the relationship with the global climate system. Because on the one hand, as we know, that our human activity is the way what we consume, what we produce, have some consequences in terms of emissions, and we know that carbon emissions and other greenhouse gases contribute to global warming. And at the same time, on the right-hand side of this figure, when the rising in the global average temperature also induced the changes in the weather patterns, it induced extreme events, such as irregular rainfall, droughts, and flood, and many things that you have already written in the chat. And it can affect our health and well-being, our livelihood, because it may, drought can destroy crop yields, and then with the reduction in crop yields, it can affect food security, it can affect jobs, right? People who work in agriculture, it can affect income. Through the effect of reduction in income, people may have to migrate. So there's a lot of both direct and indirect impact of climate change that we could think of that it affects our life. And I guess the key of my project is sort of, if it affects our life and livelihood, does it affect also demographic outcomes, including migration, mortality, and fertility? So this is the key of what I would like to investigate. And the idea of why climate change may affect population dynamics. Let's try to move the slide. Maybe I move back a little bit to talk about the population, the future population, right? Because typically, this is also what demographers do. So we try to understand not only how many people will there be in the world or currently are in the world and in the future, but also the composition of the population, the distribution also. So that when we talk about just the population size, the global population size, like in the future by the end of the century, there are three major institutes that do population projections. So one is, I think it's the most well-known, is probably the United Nations, the UN, and also YASA also produce population projection. The International Institute of Applied System Analysis, or the abbreviation is YASA, where I have based in the past 10 years before I moved to Italy. It's based in Austria. And another unit that does global population projection recently, it's kind of newcomer, is the Institute for Health Metrics and Evaluation, the IHME, those who work on global burden of disease. So they also do global population projection. I think we all know that last year, when was it? I think it was 15th of November, the world has hit, we have reached 8 billion, right? You can see also from this red line here. So maybe the question to you, if you want to speak out or you want to put in the chat, after this 8 billion in 2022, how many billion are we going to be by the end of the century? Roughly, if you can put some in the chat, or you can speak back to me. So by 2100, how many do you think, or if you may know the projection anyway, so how many people are there going to be, or projected to be? 10 billion? Yeah, Mary said 10 billion. 10 to 11, that's also far within the range, yeah. Or even some projection even say 9 billion. So I think it's if you kind of familiar with population projection, of course there are different methods that we use to do that, and it depends also on assumption. But yeah, but pretty much what you're saying, it's fall within that range. It's probably between the IHME have it slightly lower, so peak around 2065 roughly for the IHME, and then probably flatten out. For YASA would peak around 2075 to 80, and then flatten down. Sorry, the YASA is here. This because of YASA and IHME has different, apart from different techniques that they use, because YASA used a scenario-based approach, the UN used a probabilistic projection approach. So as you can see that there's a 95% uncertainty here. What else I want to say? Yeah, so the IHME, for instance, built on two quite prominent, or I would say some quite strong assumption that there would be an enlargement in female education, and you know that female education would change the fertility pattern, and also the universe. This is the strong one, the universal access to contraception. So that's why you can see that IHME have a lower projection, because typically it's a fertility behavior that drives the total number of population. Yes, also have some assumption about the enlargement in female education or attainment that change fertility patterns. So I'm saying this because I also want to get into the key component. If we want to understand how future population would look like, we would have to know like 3 components. I mean, we have to know all 3, right? We have to know how fertility has been and how is it going to evolve in the future, and same for how mortality patterns and trends are going to be in the future, and same for migration, which is probably one of the most, many of you study migration, probably one of the most volatile components to project or to even to estimate. So this, you probably know the cohort component population projection, which is a common method used. But I want to move to another thing, because I was saying that YASA used a scenario-based approach, and to build in how population would look like in the future, one could also try to think about how population scenarios would look like, and try to match with this set of 5 scenarios, which has been proposed by the climate change community already in the 5th IPCC, the Intergovernmental Panel for Climate Change report, and it has been becoming even more prominent in the recent 6th assessment report. That what they do is the climate change community, so they couple this scenarios, which is called shared socioeconomic pathway, describe how the world is going to look like into 5 different scenarios, and focusing on socioeconomic components. There's another set of climate carbon emission scenarios called representative concentration pathway, but that type of scenarios, it's about how carbon emissions are going to be, and then you can match that carbon emission scenario with the socioeconomic development scenarios to try to understand how much of the carbon emissions released in in the atmosphere, and how challenging it would be in terms of socio-economic development in the future. So there are 5 scenarios, so I don't have to go through all of them, I think, but it just shows how SSP1 is more of the optimistic kind of scenario. SSP2, it's a middle of the road. It represents the world. Let's the trends continue. Sometimes we call it business as usual scenarios, which is probably the most likely one because the past trends continue. And then we have the SSP3, which is more pessimistic because countries would, maybe I go here, countries would compete with one another, and there would be less investment in education, in health. And then we have SSP4 and SSP5. The idea of these scenarios is it depends on how the societies would develop according to the scenarios. It would pose challenges in terms of mitigation. So you can see from the y-axis here, and then the challenge also to adaptation, because if the world is getting poorer or the population are not educated, it would have more challenge to adaptation. If the world is moving more towards sustainability, more development in green energy, the challenges to mitigation would be lower. And actually, one could also quantify. So the idea of these scenarios, it's not only the narrative of how the futures are going to look like according to different scenarios. By the way, it's a scenario-based type of approach. It's quite handy when you talk to policymakers because you can kind of tell them, right? If we develop into this direction, this is what you can expect that the societies may evolve. And one could also take these scenarios and quantify it, right? So we can. So it has been quantified in many different dimensions, like population, education, how urbanization is going to look like, war and conflict, governance, gender equality, and many more. And particularly for the science, from the science side, they have also quantified how land use pattern going to be, how agriculture use going to be, and so on. So in our case, the YASA Wittgenstein Center, we also have done this about 10 years ago to quantify the SSP scenarios and breaking down, right, by fertility, mortality, and migration, by different scenarios. So the YASA projection is so built in the educational extension because, as we know, that education is quite a key driver of fertility, but also actually higher education, higher life expectancy, also to a certain extent mortality, and also migration. So it's quite an important component also when we think about the population. So in this sense, so one could try to translate the SSP into different population related kind of scenarios, and then use these to do the projection. So that's the idea of the scenarios-based approach. And as you can see, just an example here, that in a different SSP, just focus on the total population. Yeah, by the end of the century, SSP1, the business as usual or the middle of the road scenarios would project that the population would peak around 2075 roughly, and then kind of plateaus toward by the end of the century to around 9 billion. This is probably one of the likely scenarios that it could be. And also the different colors also represent different level of education, but that's not my main point here. So I talk about these scenarios because the assumption that I was showing you earlier, that we can think of how fertility is going to look like, how mortality is going to look like, how migration is going to look like, because we have to also, if we use a scenario-based approach, then we have to think. Of course, we can observe the population up until this year, up until today or this year. And then when we think about the future population trends, we have to think of what are the drivers, what are the underlying factors that can contribute to changes in population trends. We may think of the war in Ukraine, we may think of whatever factors that can affect behavior, demographic behaviors. Protests in France can be the COVID-19 economic crisis, because this all can have an impact on demographic behavior. Actually, Hugh, I'm really happy that you're here because I used your work very regularly when I talk about what are the drivers that can affect population trends, and Hugh and the teams have made this work actually very early on when the war started in Ukraine. Actually, I am curious to see your update on this as well. So I think the working paper came out around March 2022. So first trying to think of what would be the impact, right? What would be the future population? Probably, Hugh, I'm not sure if I repeat what you have already shown to the people. Maybe people already seen this work for sure. But I think the idea is, I really like this work because I think it shows the scenarios to say, if the war would end soon, of course, one shouldn't make any criticism about the work because it came out very early on in March 2022. So we don't know how long the war is going to last. But one could also think of the scenario if the war finished earlier, then maybe how many people are going to return and how the population of Ukraine is going to look like. And I think it is a very interesting exercise because yeah, one may say it may not represent the world or what has happened in reality, but it gives the space for us to think that, look, the war happened. We know that people have migrated. I think, yeah, or at least 6 billion people have left Ukraine. So one has to think of how many people are going to stay, how many people are going to return. I think it's a very interesting exercise to do. So that's one type of example of the driver that can really affect the population. Also, you may think it's maybe not only population of Ukraine, because we also have countries that take in also Ukrainian asylum seekers, refugees, or migrants as well. So it can also affect the place of destination. And I want to talk about COVID as well, because in fact, we also, so now at YASA, so in Austria, we also start thinking of also updating the population projection that the last round was done in 2014. So in the new round, with the new baseline data, we also have to think of, is there any other drivers that one have to think or take into account when we talk about the future population? And COVID-19 is one thing that we have discussed a lot. Actually, I want to place a question also back to you, put in the chat, or you can speak out. Like, do we have to take into account the impact of COVID-19 on life expectancy or not? If we think about the mortality in the future, does COVID-19 would have an impact on mortality patterns? Because all of us have lived through the period of 2020, right? So we know that we keep on. I was in Austria back then, but my husband is from Bergamo, which is the first epicenter of COVID-19 outbreak in Europe. So what we did was just watching a number every day and then seeing more and more, because if you remember back then, the Italian number kept, or at least started before other countries, so kept on rising. Even 500 excess deaths, 500 COVID-related deaths, 600, more and more. Later on, we started having excess mortality data. Then we started calculating the impact on life expectancy. So we have lived through, we have seen a huge impact. Obviously, now we don't wear the mask anymore in 2023. So we may think that it's kind of all this excess mortality, this impact on life expectancy that we observe. And one may think that, actually, yeah, maybe I'm curious to see what you think. So maybe it just affect the period life expectancy, as you see from this work, which is quite interesting as well. So the red arrows mean life expectancy has been declining, and if you see the turn, which is the gray arrow in certain countries, mostly in Western European countries, it means that the decline in life expectancy has started picking up. So it starts coming back again to the positive trends. Yeah. So so with this example, actually, it's kind of show that, okay, if we compare the average trend of 2015 to 2019 of life expectancy with 2020 and 21, we see the decline in life expectancy. But if you take the later period, I think they take 2021, sorry, 2020, we see the decline. 2021, for most countries, life expectancy already started picking up. Mind that it's a period life expectancy, it started picking up. So one could say that, okay, if I want to think about the future impact of things like COVID-19 on the future population in the next in the year 2050, so probably I don't have to bother too much to build in this effect on mortality. Possibly not, then people discuss, but there might be long COVID, and we don't yet observe how long COVID may affect the long-term morbidity in the future, which may then indirectly or directly affect mortality. So that we don't know, right? So I think it's still a kind of something that we may have to consider that. And then for some of you or many of you who may work on fertility, I guess I'm not going to show it, but also we have seen that probably the indirect effect of COVID on declining fertility, and it's persists for many countries like Italy, Korea. It's not picking up after COVID. The fertility is still not picking up. So we may have to think of that impact. So this is just to bring you into the what about climate change? If we look at the headlines, it's already there, the discussion of the potential impact that climate change may have on demographic behaviors. Things like migration, we see it quite regularly, actually. I think the media love it when there's some certain mass migration events or certain climate events, and the media like to try to link it with potentially its climate change. So in these figures here, it's back in 2018, if you remember the migrant caravan of people who moved from Central America, crossing Mexico, trying to enter into the US, and the media, actually, I haven't seen papers on this yet, say that it has, Central America was also suffering long-term drought, and that could be the driver of fight against also the unrest in the countries, and that also the unrest also drove people out of Central America to go to the US, for instance. And then this was last year, right? So it was in the UK. I think some of you were there in I think it was early heat wave. I think it was already in June in Europe, probably it was around June, and then last through also another wave in August. So there were also excess deaths, right? Also Pakistan flood. So that one was quite tough because a lot of people died directly from the floods. But after the floods, there were also spread out of infectious diseases, and also malaria, and also other diseases. So also indirectly, also there was also some effect of floods. So all of these events are also another thing that you may have come across. Some people, or sometimes you may have heard of some movement or campaign that said, let's not have kids because of climate change also. So I just want to say that this is what we have observed up until now. And if the global temperature is, unfortunately, it's on the course of rising, now the global average temperature has risen for about 1.14 degree. And we probably, I want to, for younger people, I don't want to sound super negative, but we probably on the course of hitting 1.5 degree or even 2 degree of warming. And these are the effects. Pakistan floods, for instance, or the heat wave in the UK, was already, the national scientists, they have calculated and said that this event was attributable to human-made climate change. So we may, we expect to see even more extreme events in the future, right? So, and that's the whole question about my ESC project. So if we already feel the effect of these events, and it may affect demographic outcomes, so we may actually have to build in the potential impact of climate change on demographic behavior. So that's that's what I thought, and we probably have to do so. The thing is, we don't have we have some evidence. Maybe on migration, the mortality work has been done fragmentedly by different disciplines, mainly a lot on from epidemiology, for instance. But the evidence is still like scattered around. So my rough guess is, yeah, so climate change would have impact on mortality, but to what extent, in what direction, that we don't know. And fertility is probably the field that we know very little. So my idea is, so first, what one has to do. So maybe I could skip to what one has to do. So yeah, let me skip a little bit the slide. The idea is, so we have to know what direction and to what extent does climate change influence fertility, mortality, and migration. And by saying what direction, why direction is important. For mortality, for instance, I could give you some example. So I was just showing you that there has been excess mortality from heat wave in England, right? Like 2,800 extra dead, and that was from summer. But the UK is a type of country that actually normally experience a lot of excess winter mortality, and many Western European countries as well. In fact, in many European countries, people died more when there were an extreme cold weather than extreme heat. But if we are expecting more warmer days in the future and less cold days, right? So we would expect that people may die more from heat in the future and less from cold days. In terms of population projection, you may say it might cancel each other out, and we don't have to take into account for climate change then, because people would die less from extreme cold days, die more from extreme hot days, and there may be harvesting effect also. Then we probably don't have to bother. The thing is, I think even though we don't have to take into account for climate change on mortality patterns, maybe yes, maybe no, we just don't know yet if we do have to. And I think this is the kind of work that I want to do, and also to what extent, right? So not only the direction, but also how much. Maybe when you do some work, it's always, yes, we found significant effect, but it's like it would change the behavior by 0.1%. So at the end, the coefficient is significant, but probably it doesn't have such a meaningful impact, for instance. So I think the extent size is also important. Also, yes, and then also I think I mentioned a lot also that this is one thing very important, that the effect is not going to be the same. It would varies by demographic characteristics and many things that we have to consider, things that we have always done. We always look at differentials of mortality pattern or morbidity by demographic groups, and it's going to be the same, because we know that, for instance, if we talk about heat wave, it's an older population, and which going to be more susceptible. But if we talk about climate impact on food insecurity, that's going to be children aged under 5, that is particular, or pregnant women, which is particularly susceptible to food insecurity, right? Because that could affect their health. It may even affect increase the infant or child mortality. So this subgroup analysis is extremely important, and also we don't know much actually what are the mechanisms. That's also another side that the project want to investigate, and finally it's about how climate change may impact future population size. But the last question, I think, first we have to build on what we have observed up until now about the impact of climate change or extreme climate events on fertility, migration, and then we can think of what we're going to do for the future. So that's the idea. And how are we going to do it? You may notice I haven't really mentioned like what countries or what time period. So I'm very greedy. So I'm going to do whatever I have the hands on the data. Of course, it's maybe too ambitious, but I think up until now we have compared to when I did my PhD. So I finished my PhD in 2008, and I think back then we didn't have like that much amount of data or computing power, or I don't have as good coding skills as many of you now, for instance. And it's much easier. Now you can just write an R code, Python code, you get some climate data, satellite data from the web. Someone really wrote the code for you even. So you take that in, you match, you use the spatial data, you match that climate data that tend to come in like a raster type of data, come in grid cell, and then now we have also more of demographic type of data. For instance, the IPUMs, many of you may know the harmonized microcensus data, which allows us to look at the subnational region, right? So we are able to maybe look at some demographic behavior at the smaller scales. And I emphasize that it's important when you want to work on climate-related type of demographic outcomes, because of course, if you take countries like, say, India, the climate of India as a big country, and look at how it affects mortality, for instance, that would be too coarse. So what we would want to work at a subnational scale, or the small refined geographical region. So one could match that type of small region data, match it with the climate, the local experience of irregular rainfall, and then match with other types of environmental data. So that's the idea. And the typical type of modeling approach, it's not fixed. It has to be that way, but I think it's also relatively simple. So whatever y on the left axis, right? Whatever the outcome that I would be interested in, or we would be interested in. Yeah, just use example of people who vote for Green Party. So it can be migration, for instance. So migration could be an outcome, and then we would add whatever control we have, but typically you tend to use the time fixed effects or the region fixed effect, maybe even season fixed effects, so try to kind of already control or account for the fact that different region would start with different kind of climatic zone, right? So we should account for that, because if we start with dry region or wet region, so it's not going to be the same impact. So we account for that. The time period also make a difference, and then look at how climatic events, which typically would measure the climatic events before we measure the outcomes, sort of exposure to can be floods, can be droughts, can be extreme heat. So there's a lot of way to measure climatic factor as well. And I just want to emphasize that there's no right or wrong. Typically, if you are interested to do this kind of analysis, you may look at what other literature have been used. Epidemiology have their own kind of climatic measurement of climatic variables. Demography, geographers tend to use similar things. So try to be consistent with the other, but there's no fixed way to say that this is a heat wave, for instance. Yeah, actually, that's talking about heat wave. This is quite interesting, because if I measure, if to define what is a heat wave, you may take the temperature data, and then you say that you take the 95th, whatever, take the distribution of the temperature across a certain time period, and see that if August 2022, you observe that the distribution, it's extreme, right? It's above the 95th percentile, 90th percentile, whatever you want to make the definition. You may say, okay, it's extreme from its own distribution. That could be one way. Or you may say that when we work with Austrian data, we would say that the days that the maximum temperature, you can use maximum temperature, or you can use average temperature of that day. That's a sort of subtle difference. It's above 30 degrees. So that's in the case of Austria, we count this as heat wave. And then when I present something like this for Italian audience, or even people from India, then they would say 30 degree is not a heat wave, because the baseline is different. So that's also, it varies also on what context you are talking about, what measurement. So I have to ask the organizer that I should stop and leave time for question, or I have tons of slides and I could go on talking about it.
Many thanks, Raya. Actually, I'm sure I cannot share my video, but if you want now to take questions, so then that's all fine.
Yeah.
So first of all, many thanks, thanks indeed for this fascinating talk.
So
Raya.
maybe I can skip to the last maybe. So I have some evidence on migration, fertility. I have a lot of ideas that I can do, but I think, yeah, exactly. So I could share the slide as well, and then.
Right, it's up to you if you want to carry on another 5 minutes, or you want to take now questions and use these slides to answer questions.
I do this last one, and then I would close. Yeah. So so as I said, so what I would do is for all of the 3 outcomes, so fertility, mortality, migration, I have worked quite a lot on migration, so I do have some idea, like probably climate-driven migration. It's likely to be within the country, so that's more common. So if we want to build in that assumption in the population projection, so that rather than we would have mass migration from Africa coming to Europe, that's due to climate change. That would be, at least from what we have observed until, that would be unlikely. So it's going to be more internal migration, for instance. So that. And then go on to work on fertility, and also try to maybe do literature review, in particular for mortality. Then once I have all of this information, the next step is to collaborate, obviously, with my group in Austria. So, since we're going to do anyway the near round population projection. So this is a typical way that the YASA team has worked on. So use the expert survey. So in the future, you would get the surveys from us and then ask the demographers and think of what would be the likely scenarios in the future, right, that could affect, or in this particular example that I put, it's a mortality trend, for instance. So one may think that improvement in medical technology will contribute to declining mortality. Is it how much likely it is? So we ask them over for a different set of questions. Then we can think of building in the kind of the climate related information as well, which we have done 10 years ago, but mostly these events were not considered to be important to affect mortality. But nowadays it may be, right? So that we can also improve in that. And I would, at this point, I stop here, as I said to you. And then we just launched our website just now, and also the Twitter. Yeah, I stopped sharing as well so I can see everyone. Yeah.
Many thanks, Raya, indeed, for this fascinating talk, especially giving an overview of your research project, and also making it very interactive. And apologies if we were not as active as we expected, but now is a time for questions, and everyone knows the rules. So please use the raise hand function or type your question in the chat box, which already has been actively used. So who would like to start?
No hands, not in the chat.
Right, let's wait for another 10 seconds and then see if anyone is going to ask a question by raising the hand. Yes, Katie, please. Thank you for starting the discussion.
Hi, Raya. Thank you very much for that talk. It's my first introduction to this work about climate change and population, and forgive me if my question is a little bit naive. I'm interested to know more about how you're planning on including feedback loops into understanding projections and how that works from a modeling perspective. Do you, for example, use things like agent-based modeling, or is it all based on different kind of simulations where you assume that this much feedback will happen and then you model it? I'm just kind of interested to know what the modeling strategy is.
Yeah, so I typically, if I were to do it, yeah, so I would just probably extract from the empirical, so the regression that we observe.